everybody, welcome back. This is Unit 5, Lesson 4, and in our notes, we are in Section 3. So take a minute in your notes, flip over your flowcharts, and find Section 3 that deals with types of formulas. Because we have learned how, given the formula to write the name, we need to be able to go the other way. Given the name, write the formula, which is easier, so don't worry. There are two different types of chemical formulas that exist, and it's on page 64 there, section 3, and you have to write this down. The two different types are empirical formulas and molecular formulas. So you may want to draw that space in half, and on the left side we'll write everything we need to know about empirical formulas, and on the right side we'll write everything we need to know about molecular formulas. So an empirical formula, which I abbreviate EOFO, only because it's fun. Okay? My smart board's a little misaligned here. Let me just align it real quick. Sorry about that. So an empirical formula, which I call EOFO, or an empirical formula, is basically a formula where all of the subscripts are in lowest possible terms. It's the simplest or reduced formula. All of the subscripts are only divisible by 1, no other number, and they all have to be divisible by the same number, right? But in a reduced formula, the only thing they're divisible by is 1, okay? So they are reduced as much as possible. Some examples of things that are empirical formulas are like water, okay, or sodium chloride. If you notice, okay, in water or sodium chloride, the oxygen in water has a subscript of 1, so there's no other number you can divide both the subscripts of hydrogen and oxygen by. Same thing in sodium chloride, they're both 1 here. So there's no other number that you can divide those subscripts by other than 1. Something that's not an empirical formula would be this. This is the formula for hydrogen peroxide. If you notice there, both of those subscripts are divisible by 2. Right? Which means this is not reduced. Which means it's not empirical. And if it's not empirical and it's not reduced, then what we would call it is molecular. It's a molecular formula. A molecular formula is officially defined as the exact recipe of all the elements in the compound. It's how you would make the compound, okay? So this hydrogen peroxide is an example of a molecular formula. And if I abbreviate empirical formulas EOFOs, I abbreviate molecular formulas MOFOs. They are the exact recipe of how you make the compound. In order to make hydrogen peroxide, you need 2 hydrogens and 2 oxygens. These subscripts are not reduced as much as possible, though they can be. Like another example of an empirical formula would be water. How do you make water? You need 2 hydrogens and 1 oxygen. So the subscripts may or may not be in lowest terms, but the idea is they're an exact recipe. And if something is not reduced, then it's definitely considered a molecular formula. Okay? So there's 2 different types of formulas, empirical and molecular. And when we write formulas, most of the time we're going to be writing molecular formula. So in your notes, you have 5 examples. I would like you to identify them as either empirical, the subscripts are reduced as much as possible, or molecular, the subscripts are not reduced as much as possible. Okay? And basically you just write either molecular, and I'll do the first one for you. Since 2 and 4 are not in lowest terms, that is a molecular formula. Okay? So for tonight, I want you to go through the remainder of these and identify them as either molecular or empirical. And for anything that you write molecular down, I want you to reduce. reduce all the molecular formulas to give the empirical formula. So for example, okay, I can reduce N2O4 by dividing both subscripts by 2 to give me N1O2. That would be the empirical formula for this molecular formula. So what you may notice is that when you go from the empirical to the molecular, you're really just multiplying those subscripts by some whole number. So the molecular formula is always a whole number multiple of the empirical, okay? And the number we would have to multiply those subscripts by would be obviously 2, and that would give us the molecular, right? We could go just multiply all those subscripts by 2 and we'd get the molecular. So again, identify these as either MOFOs or EOFOs, either molecular formulas or empirical, and for anything that you code as a molecular formula, reduce it to give me the empirical formula. That's it for tonight, everybody. Have a great night. Bye-bye now.